Hello everyone, this is Students Quest. In today's video, I'm going to answer a question asked by one of my students. So the question what you see on the screen, I encountered with this question several years before when I started my teaching as a career. So that time I was perhaps failed at the first attempt when I first saw the question. I tried a lot of things and I was novice that time in teaching, very little experience. So I remember perhaps I solved it with trigonometry and all. That was a very lengthy calculation. But this time when I got this question, I tried in a different way that I wanted to share with you. So let's see it. So here what the question is asking is to evaluate the ratio of these two quantity. The first quantity in the numerator is n goes from 1 to 99, square root of 10 plus root n, and the denominator is n goes from 1 to 99, and this is the conjugate of the same numerator. So what is the technique? There are many such other ways, but what I actually observe how we can do it easily is this one. We can just write this complete R as a ratio, this complete ratio as R, and that is going to be n, this is the numerator, and this d is the denominator. So here n I mean to say is this is n goes from 1 to 99 and summation 10 plus root n, and d I mean to say that the conjugate of it, n goes from 1 to 99 and 10 plus root n. It means the ratio what I have right now is the summation n goes from 1 to 99 and square root of 10 plus root n, and the denominator is n goes from 1 to 99 square root of 10 minus root n. Now notice one thing, that we have done this kind of questions many times in which we make this inside term as a perfect square. To make the perfect square, I need 2 over here. So what I'm going to do is, I am multiplying and dividing by root 2 so that I can insert the 2 inside the square root so that I get the 2 here, and after that we will think what we can do. So what we do here is summation n goes from 1 to 99, and this is going to be 20 plus 2 root n. In denominator again same thing, summation n goes from 1 to 99, and this is square root 20 minus 2 root n. Now the problem with this is, maybe we can handle the 20 and all. Let me delete all these things. Now the problem with this thing is we can handle this 20, but 22 root n, how we can think as a 2 times ab, because I need the perfect square. It means I need a squared plus b squared plus 2ab. Perhaps I can think this 20 is root 10 square root 10 square, or maybe something. But there may be a perfect match so that it will give you the a squared plus b squared plus 2ab. For that, there is a very simple technique. The technique is, when n is starting from 1 to 99, this is going to be 2. You can see here what I mean to say. This is going to be 2 root n. What I want to make it is 2 times a into b. For that, with root n, there is no such hope I have. So what I'm going to do is, I am applying the King's property, so-called, what we apply for this integral technique. The same thing we can apply for the summation. And how we did it? We are taking a plus b minus, this is a plus b minus n. So this is going to be 100 minus n. if the king's property is not striking or not making sense, we can think in this way. Since you are writing the summation starting from 1 to 99, it doesn't matter you write in which order. If you're writing this 20 plus 2 times 1, the first term, plus 20 plus 2 times 2, second term, and so on, even if you reverse the order starting from the very end, the summation will be the same. So here, if you do the same thing, k is equal to 1, you substitute, you get the last term, what you get here. And the same way, the second last term, the third last term, and so on, and all the way up to 1. So this is basically the same summation what you did here. But in doing so, we have a benefit of making the perfect square. That's why we are doing this. So this is 2 times 100 minus n. And what is the benefit now we got is this one. Notice the numerator here, k goes from 1 to 99 as it is. But here, this 20, let us say 20. But this 100 minus n, I can write as a square root of 10 plus n into square root of, 10 plus root n minus, into 10 minus root n. Because when you multiply these two square roots, you get 100 minus root n again back. So the same thing we are going to do in the denominator, and that is going to be 20 minus 2 times 10 plus root n and 10 minus root n. Now notice this 20 I can write as, let's say this is our a and this is our b. It means 20 is nothing but the a square plus b square. It means I have exactly this as a and this as b, because when you square and add them, you'll get the same thing. So what I can write directly is the summation k goes from 1 to 99, and this is nothing but the square root of the a is 10 plus root n plus b is 10 minus root n. I don't think this is so difficult to understand this thing, because again I'm explaining it. This is a going to be, and this is b, and of course this 20 is the a square plus b square exactly, because when you do this square, the root will go, so 10 plus root n by the way here, and 10 minus root n, and you're adding them, so root n and root n will get cancelled and get 10 added 2 times, so that will be 20. In the denominator, you get the negative here in the middle, so you get a minus b the whole square, and that is not difficult to understand. This is going to be this, and minus 10 minus root n square root and the whole square. So what I'm going to get now is the bigger square root, the outer square root will go away, and I'm getting here the summation k goes from 1 to 99, and this is 10 plus root n square root and plus 10 minus root n square root. In denominator, the same thing with a minus sign. So I'm not going to write it. Summation k goes from 1 to 99, and here same thing, and here same thing with a minus sign. Now try to think this way. This was the whole ratio r, and now we can separate the summation to the two pieces. So two piece, what is the first piece? K goes from 1 to 99. This is 10 plus root n square root. The second piece is summation k goes from 1 to 99 and 10 minus root n. Why I'm writing k by the way? This was n by the way. So n I have written up to here, and again I've made the mistake. I'm writing k every time. Perhaps there's a mistake. So everywhere what you see k here as a summation, that is I mean is n. So I hope that will not give you any conceptual fallacy to you, and just excuse my this kind of negligency. Okay, so this is going to be 10 minus root n, this thing, and now here I am writing summation n goes from 1 to 99 and 10 plus root n and here also minus summation n goes from 1 to 99 and 10 minus root n. Now what will happen that you already assume that this is the n and this is d with numerator and denominator. So I can replace this is going to be numerator, as you can see better. This is n, this is d. This is n, this is d. Let's substitute it. So what I got is the r is nothing but the n plus d divided by n minus d. Now notice I have to evaluate the value of r. So what I'm going to do, I'm dividing this ratio with d. So we get r, because n by d will become r. So r plus 1 by r minus 1. So we got a quadratic equation which is r is equal to r plus 1 by r minus 1. Let's simplify this. So we get r square minus r minus 2r and minus 2 perhaps, no, minus 1. So what we get is r is 2 plus or minus the square root of 4 plus 4, 8. That is going to be 2 there. So we get 2 plus or minus 2 root 2 by 2. So we get two values, 1 minus root 2 and 1 plus root 2. Since 1 minus root 2 is neglected because I don't need the negative number, because we are adding all the positive numbers in the both numerator and denominator, and that is going to be the answer. I think we can do better here. So what we can do better, let me just copy this question again and let's see how we can do better. We don't have to do this much as well. We can do better in this way. So what's better is we can take this r is equal to n by d as usual. And now I'm taking the numerator here. So please understand carefully. This is n goes from 1 to 99 and this numerator I have taken only. But notice I have to involve the denominator as well. So what I'm going to do is, since I want to make this as a perfect square again, so there's no denominator here. So I'm multiplying root 2 both sides. So this will become root 2n on the left hand side. And here I will get summation n goes from 1 to 99 and this is nothing but 20 plus 2 times root n. Again, since I know that to make the perfect square, again I have to apply that so-called King's property. So that is going to be 2 times square root of 100 minus n, and again this perfect square will come there. So this is root 2n, and sorry, capital N by the way. And here I will again, I'm not going into detail because you know how to do this. So this will become again 10 plus root n, the square root, and plus summation k goes from 1 to 99, 10 minus root n with the square root, because we get the same thing here back there in the numerator when we did the first method. So what is the benefit of it? You notice that this is root 2n and this is again I can write as a numerator, this is a denominator. So this is root 2n and this is numerator and plus denominator. What I need? I need the value of r. So what I do? I need n by d. So what I do here? Root 2 minus 1 times n is equal to d. And since I need n by d, I can write n by d is equal to 1 by root 2 minus 1. You make the, what we call, we rationalize the denominator. So we get n by d, which is the r, which is the desired value, is root 2 plus 1. So in this way, we don't have to do that much calculation as well. In 4 or 5 steps, you can do this. The only key factor is we have to apply that so-called King's property in this to make the perfect square inside the bigger square root. So that's all for today. See you in the next video with some other such interesting questions. Stay math active.